Hi, everyone. Good morning or good afternoon if you're joining from somewhere other than the Western world or the North American world. My name is Greg Council, and this is going to be kind of an informal discussion around intelligent document processing or intelligent capture or document capture, however you want to call it. So we're going to be hosting these sessions on a semi-regular basis, probably twice a month, depending on if there are holidays and everything like that. And the purpose is to just go over some brief topics at a very high level, and then open the floor up to any kinds of questions or anything like that. So 30 minutes in and out. Depending on how it goes, we might move this to the afternoon and call it cocktails and capture. You never know. All right, so without further ado, I'm going to go into our first topic. So the first one that we're going to talk about is how many samples. So as long as I've been in this industry, and it's been longer than I'd like to admit, one of the biggest questions that organizations that are wanting to implement intelligent document processing have is, okay, how many samples do I really need? A lot of times they think that they understand that, but when you really ask and you start pressuring them to provide an answer, they start to have a blank stare. And so I want to just take 10 minutes to talk about some high-level concepts that'll help you frame how many samples. So scope of samples, there are really two aspects that drive how many samples you need to use. And there are two areas where you're using samples. The first are samples used with configuration. Now, if you're using machine learning, these are typically called the training set or the learning set. The second one is how precise you want to measure the system. So two separate aspects, because some of it involves some, not heavy statistics, but it does involve things like confidence intervals and things that are probably too complex to go into over 10 minutes. So we're going to focus on the precision and configuration. Okay, so with precision and configuration, intelligent capture, and you might have heard me talk about this before. I kind of beat this one to death, so to speak, but I'm going to continue to do it because it's really important, is that intelligent capture is very different from other types of systems, things like procurement systems or CRM systems, because the real focus of intelligent capture is on optimizing the comprehensiveness of data that you can get out of unstructured information, being documents, and the precision or the accuracy of that information that comes out. So unlike other systems, the real focus is on something that involves a lot of measurement. And the number of samples is really a necessary thought process that you have to go through, and you have to collect these because the number of samples you use to configure a system is heavily important in the outcomes that you expect. So it's really driven by the number of documents within your scope. So the documents being the document types. It could be contracts, it could be purchase orders, it could be bills of lading, it could be medical charts. But it's really driven on how many document types you have within the scope of your project, and just as important, the variance within each document type. Classic example, invoices. If you're going to deal with one vendor's invoice type, it's not a whole lot of variance. So chances are you could get by with one sample. But if you're going to deal with invoices from a number of different types of vendors, let's say you're a large organization and you deal with 2,500 to 5,000 different vendors and you're processing invoices from all of these types of organizations, even though you have one document type called invoice, you've got potentially 2,500 to 5,000 different variants within there. A laudable goal always is to have an example of each one of those variant types. So an example of an invoice, and then an example of each variance of those invoices, or an example of a medical chart and an example of each variety of a medical chart. So it's always a laudable goal, but that's not always practical in practice because, gee, it's really hard to collect all of your production information and then to sort through it and verify on a one-to-one basis that you do have one in there. But ultimately, you want to be able to get some level of representation, a really good level of representation when you're using to configure a system. So it could be if your scope involves 10 document types and you have 3 variations of each type, while your effort should be to get 30 samples, and in case in like a very limited amount of document types, you can do that, but you want to get some percentage in there. Here's a little table that we have, and we have a larger ebook that covers a lot of these things, a lot of these data science aspects with intelligent document processing. Now, this is an example of a mortgage document classification and separation project where each one of these bars that you see here represents a document type, okay? Now, the length or the height of each one of those bars represents the variance. So let's look at closing checklist. That is a document type, and the bar is kind of a little bit higher relative to these other bars. And what that indicates is that the variety of closing checklist documents can be significant depending on the number of lenders you're dealing with. And the same thing for appraisals. I mean, if you've ever purchased a home and gone through that, you can look at your appraisal document and see that the layout, the placement of all the data is highly dependent, and actually the number of pages is highly dependent on the appraiser and what type of format they use. So looking at this, let's take an example, and you see this line along the top here. The sample set includes only a portion. So this is an example of an unrepresentative sample set where I haven't taken all of the documents within my scope of document types. I've only taken a subset of them. So, you know, I've taken the appraisal and the credit report and the bank statement and the ID and the builder certificate, but I'm going to miss out on all these other documents in orange. And that's not representative of what you want to do. Another example of lack of representativeness is this line that we draw here. So if I take the same number of samples, regardless of the document type, chances are that for my credit report and my appraisal and my bank statement and my closing checklist and these other documents, the samples are not going to be representative of true variance. So it's not, again, I'm going to be building a system that doesn't take into consideration a lot of these other different types of document variances. So this is an example of the right way to do it. In this sample set that we've collected, we've got examples of all the documents within the scope, all the document types. And additionally, we're adjusting the number of samples within each document type based upon the variance or the expected variance of each one. So in this case, we've got more samples, input samples, for credit reports or the higher variance documents than we do for the structured forms like loan applications. I mean, quite simply, if you're dealing with a form and you're only dealing with one form layout, despite the issues that you might have with scanning quality and that type of thing, you're going to have a very standardized document, so you don't need as many samples. So this is the right way to do it. Now let's talk a little bit about machine learning, because I'm talking about configuration and sample sets. And within intelligent document processing, you always want to, whether you're doing it manual, configuring a system manually or using machine learning, you always need to have a lot of focus on the input data set. And with machine learning, it is even more so, because you're seeding the functions or the tasks of actually configuring a system using rules with using machine learning algorithms that are a lot more opaque. You can't really understand why the outcomes are there. And so the only real way to really understand why machine learning algorithms behave the way they do is to look at the input data sets. And this is one of my favorite quotes from Charles Babbage, which basically says garbage in, garbage out. So when you're using machine learning and when you're working with a system that really uses machine learning algorithms instead of expert systems, rules-based types of methodologies or mechanisms, the emphasis on having a really representative data set just becomes that much more important. But there are ways to make it simpler. I mean, if you would have asked us 5, 6, 7 years ago, how many samples do you need? We would have typically said thousands, and the more the better, right? Especially if you're doing it and you're taking a statistically representative sample set. But there are things that we can do to make it simpler. One is using or relying on machine learning algorithms that aren't as data hungry. So I think everybody has heard of deep learning by now, but there are a lot of other different types of machine learning algorithms for the support vector machines and other types of ways that you can train a system that aren't as quote unquote data hungry. So they're not as reliant on large volumes of sample data to be able to come up with a really good outcome. And our systems, what we do is we don't solely rely on deep learning algorithms, although they're very much present within our software and within smart learning. We also use a number of algorithms that perform a lot better on lower or smaller size sample sets, and that's one way we can do that. Another way is provision of pre-trained models. So wherever we can, we collect sample sets and large sample sets and then pre-train our models so that despite whether they're deep learning or otherwise, we can deliver something more out of the box that you can use pretty much immediately. But the benefit is that you can take that model that's been pre-trained, that knows how to find specific data on specific document types, and then gradually fit it to your specific data set. So it's kind of like having your cake and eating it too. You can get something immediately day one, and then over time it starts to fit to your specific data. And the other one is you can kind of kick the can down the road, so to speak, where you're collecting data, you erect a system, you're collecting data, and you start with a low level of performance initially if you're not using a pre-trained model, and you can curate data automatically using systems. So our smart learning system has a data curation function which will analyze production data, the outputs, and then gradually collect it so that it fits your production information, and then uses that to learn. So the idea is that over time, these models become a lot more efficient and they can be adapted as well. So that is it for my short little topic on how many samples. At this point, I'll open it up to any questions that we might have. I want to make this very interactive and conversational, so no question is in or out as long as it deals with intelligent document processing. So let's go ahead and open up the phones.